Hi, this is Julie, and in this video, I'm going to talk more about using if statements by exploring more about how we can compare data. So I'm going to talk about relational operators, logical operators, how we can compare ranges of data, and precedence rules. So first, let's talk about relational operators. And when we use these operators, we're trying to compare two values. And the result of this comparison is going to either be true or false. So these first four operators, you've probably seen in math class, where you would compare two numbers to find out if one of them was larger than the other or less than the other, and so forth and so on. With each of these operators, you would have a number on each side or an expression on each side of the operator. Now in C++ programming, we have two additional operators. We have the equal operator, where we're testing to see if two things are equal or equivalent. And then we have the exclamation mark equal operator, which is trying to test if two things are not equal, basically the opposite of equal. Now, there's a big gotcha in C++ with this, and this is a source of a lot of errors, because equal and equal are different, but it's easy to put the wrong one in. An equal sign by itself is an assignment operator. And what we're doing is trying to take a value on the right side of the equal sign and assign it to the variable on the left-hand side of the equal sign. But if I want to test if two things are the same or have the same value, then I'm going to use it with two equal signs. Like here, where I'm testing to see if x is equivalent to y. And so when I want to test for this, if I had a situation where x had a value of 4 and y had a value of 5, I would compare the two values. 4 is not the same as 5, so I would say that that test is false. But if x had a value of 3 and y had a value of 3, and I wanted to compare those two values, then I would say that that comparison is true. So let's look at this in some code. So let's look at how we can use the equivalence operator in code. I want to compare variables x and y, and if they're the same, I want to display that they're the same, or I want to display that they're different, and then I want to show their values. So at the top here, I'm giving x the value of 5 and y the value of 10. When I compare x and y's values, 5 and 10, they won't be the same or equivalent, so I'll skip over the statement that says same, and I'll go to the else statement, or the statement following the else that says cout different. Then finally, I'll display the value of x and y, and my output will look something like this. It'll say different, and then 5 and 10. But if I were to rewrite this code with just one small difference, instead of using the equivalence operator, I forget the second equal sign, and I use the assignment operator. Now I'm not testing to see if x and y are equivalent. I'm actually going to assign y's value to x. And when I do this assignment, the compiler is going to consider this to be true. And so this will be a true statement, and I will see the word same. So again, if x were 5 and y were 10, I'm going to assign 10 to x. I'm going to show same, and then when I display their values, I'm going to see that they're both 10. And usually this is not something that we wanted to do. This is usually an error. It can be a bug that's hard to find, because I'm probably not wanting to change x's value here. I can also use the equivalence operator to do other things like test to see if a number is even or odd. So in this example, I'm going to get a number from a user, and then I'm going to use my modulo operator to see what happens when I divide that number by 2. If I don't have a remainder, then it's an even number. And so I'm going to compare the result of that modulo operation, number mod 2, to the value of 0. And if I had no remainder, that will be true, and I will display even. But if it were a number like 5 mod 2 has a remainder of 1, that expression would be false, and now I would display odd. Now let's look at logical operators. With logical operators, I want to combine two test conditions. And the first operator is a double ampersand, and it means and. So when we use this operator, the effect is if both test conditions are true, then the entire condition is true. We use the double pipe symbol, which is a symbol above your enter key, to mean or. So when we combine two conditions with the or operator, the overall test condition will be true if either are true. And then finally, we have an exclamation mark that means not. And so what it's going to do is take the reverse of whatever we have, or negate it. So if we had something that was true, now it would be false, and if it were false, it would become true. And a good way to study all the combinations of these are with something called a truth table. So first, I'm going to look at AND operations. When I'm using the AND operator with the double ampersand, both expressions have to be true for the overall expression to be true. So if I have true and true, that's going to have a value of true. But if either side or both sides are false, the value will be false. So that's true and false and true, or false and false. So with the AND operator, we have four possible ways, or four possible expressions, and only one of them is true. Opposite is for the OR operator. The OR operator, either side can be true to make the overall expression true. So if I have true or true, true or false, false or true, any of those three expressions is going to have an overall value of true. The only time an OR expression is false is when both sides are false. So let's look at some examples here. In each of these examples, I'm going to use the integer variables a, b, and c. A has a value of 5, b has a value of 10, and c has a value of 15. So first, on the first line, I'm going to compare c to a. Is c greater than a? Yes, it is. And is c greater than b? Yes, it is as well. 15 is greater than 5, and 15 is greater than 10. So the left-hand side is true, the right-hand side is true, and the overall expression is true. On the second line, I'm first going to compare b to a. Is b greater than a? That's 10 greater than 5, and that is true. And on the right-hand side of this, I'm going to compare B to C. Is B greater than C? Or is 10 greater than 15? Well, that's not true. That's false. So what I have is true and false. So the overall expression in the second line is going to be false. Now, if we take that same expression and we use an or symbol instead of an and symbol, B greater than A was true, B greater than C was false, I'm going to have true or false, and the overall expression will be true. In the fourth example, I can compare A to B and A to C. So I'm going to say, is 5 greater than 10? Well, that's false. And I'm also going to say, is 5 greater than 15? That's false as well. So we have a false and a false, or false or false. So having two falses is going to make the overall expression false. And then in the last example, I'm going to use the not operator. So first, I'm going to compare A to B. Is A greater than B? Is 5 greater than 10? Well, no, it's not. So A greater than B is false. But because I'm using the not operator, I am going to take the opposite of that and turn the false into a true. So now I have true on the left-hand side. On the right-hand side, I'm going to compare C to B, and I'm going to say, is 15 greater than or equal to 10? That is true, and so I have true and true, or the overall expression is true. And so here I'm showing each of these values that we worked out in this problem, or in these 5 examples. When we use logical operators to combine relational expressions, we can create long and complex expressions. But when we're writing program code, our goal is to write statements that are easy to understand. It's easier to debug simple statements, and if someone's coming behind us later to modify our code, we want them to be able to understand what we were doing so they can easily change it. Here are 2 statements that do the same thing, but one is harder to understand. I want to compare the Fahrenheit temperature of water to 212 degrees to determine if it's boiling. Well, a simple way to write this is, if temperature greater than or equal to 212, water is boiling. Here's another way I can write the same statement. It's going to have the same output, but it's harder to understand. Now I'm going to compare temperature to less than 212, and whatever that expression's value is, I'm then going to negate that and take the opposite of it and reverse it. So now I have multiple things going on. I'll have the same result, but it's much harder to understand.